Pre-Calc friends. This is Miss Eisencraft here with a little reminder of what function notation is. So this is introduced as early as 8th grade in middle school for many of you, but there seems to be some confusion about it. Some people kind of understand it, don't understand why we use f of x. So this is just going to be a general overview. So first of all, to understand function notation, let's really remind ourselves what a function is. A function is a rule that assigns every input one unique output. So if you think about it, x needs to go to one unique y value. Okay. So one way we often describe this or model this is we first introduce it. We say, okay, a function can be kind of thought of as you're feeding a machine input values and outcomes output values. Okay, and we modeled this in middle school with an x and a y on a graph with an x and a y, right? And even in equations as y equals something with an x in it, right? Okay, so y is the answer, x is the input. But what we're saying here is we're just defining it a little bit more clearly. We're saying x is fed into the function. The machine is called function, and we're going to call it f. Right? So this is called function f. You can call it another name. Okay. And then the output, we say it is the value of f when assigned an x, or f of x. So f of x altogether replaces y. Okay, so you can replace it here. You'll see it replaced here. Think of it as the output. You'll see it replaced here, and you'll see it replaced here. It does not mean f times x. It means the value of f at x. Okay? So if you do get confused, and I know this is often taught to you, if you get confused at what f of x means, you simply substitute y and f of x mean the same thing. So if you get super confused, you can just replace the whole f of x with a y. But we want to kind of refrain from doing that. We want to understand why function notation is used. And function notation is used, I also wanted to show you that you can use it in ordered pairs. You'll often see it like this. Okay, so then they're going to replace that. And so it'll say x, f of x, holy parentheses, right? All right, but the reason why function notation is used, let's say we are looking at the volume of a sphere. So maybe you remember that the volume of a sphere is 4/3 pi r cubed, right? Everybody knew that, had that memorized? Okay. So another way to say that, we could then track a bunch of this, say, okay, what if the radius is 1? What if the radius is 2? What if the radius is 3? What if the radius is 4? What would the volume be, right? So this is your input, this is your output. What function notation allows you to do is it allows you to see all of it like in the equation form. So like the volume is a function of the radius. So if you were asking what the volume V of 1 is, you are asking what is the volume when we have a radius of 1. Okay, so you can plug it in. You can actually calculate it. Okay, and you would actually get V of 1 equals a number. So you can actually see what numbers you're plugging in instead of this just saying y equals answer. You realize what input was plugged in and what output it gave you. So it's important to know that this number here, the number inside here, is the input. And the entire f of x is the output. So think of it that way. So x is the input, right? And f of x is the output. Let's try something kind of simple. And I promise we will be done. Let's try like a simple parabola, something like this. Let's do the equation. Let's say we had y equals 2x squared plus 3. So in function notation, we would say, well, f of x equals 2x squared plus 3. Okay, so this here is our input. So if we think about it, we are asking if we were to make a t-chart, right? And instead of y, we're thinking x and f of x. If somebody said, well, what is f of 1? Well, this is your function. It's asking, what would this equal? What would the output be when the input is 1? So what would happen if you plugged a 1 in there? Okay, then you would put the output there. If they said something like this, f of x equals 21, they're not asking you to plug in 21. They're saying what was plugged in, what was the input when the output was 21. That can be confusing or can get confused. Kids will accidentally swap it and think that's the input. So if they give you the number in the parentheses in function notation, they're giving you the input, asking for the output just to calculate it, or maybe they're giving you the output and asking you for the input. Okay, and you could either graphically look at that or algebraically solve. So in a graph, again, you can just generalize all of this in all of its representations. If this is x, and typically we think of this as y, we can also think of this as f of x. So let's say that parabola just made this shape or something, right? If we wanted to know what f of 1 was, we would go to 1, that's your input, on your x scale, right? And we would follow it up and we would figure out what is the output when the input is 1. If they said f of x is 21, they are in fact asking you, okay, go to your output of 21, right? And what is the input? Now, an output can have 2 different inputs. That is okay. It's just that an input can't have 2 different outputs. Super clear, right? All right, so f of x, so then you would find 2, so you might have 2 values. I think this one happens to be 3 and -3. Okay. Hope that's a good reminder, but in general, f of x replaces y. Think of f of x as the output. You can think of it in equation form. Graphically, if you get confused, you can think of the input and output table, or even the little input output machine.